topics. Understanding the guitar amp system. There's a few short videos in this that are going to suck up half the time. And I'm sure all of you have heard of the idea of a flipped classroom or a hybrid classroom. I don't do flipped classroom stuff all the time. I do some hybrid classroom stuff occasionally. For this topic, for STEM guitar, this is a lecture I've done for years. Lots of hands-on demonstration. And finally I decided I'm just going to video this and have the students watch it at home and then allow them to play with the stuff when they come into class the next time. I'm not going to show the whole thing because it is a bit long, but I am going to show the first few minutes of it so you get the idea. Just click on that. It's embedded. Oh. There usually is a button right here that plays. It's not that. That's a footer. Well, shucks. Well, it's a good video. I click play. No, that didn't work. Got any ideas, Tom? Usually it shows up right there with a little play button on it. That's the last presentation. Oh, there it is right there. You know, we'll just have to play it without, that's the play bar. Oh no. Okay, then I'm going to pretend there's a video here playing, and I'm going to tell you and show you what the video is about. What I have is, I start off with a small electrochemical cell, and a wire and a compass on the table, it's orienteering compass. And I go through Orsted's 1820 experience where students in the classroom were heating up a wire by touching it to their voltaic pile and noticing that the compass that was nearby, the needle was moving. And I point out, well, holy cow, what happened? They suddenly discovered there's a relationship between electricity and magnetism. And then I move on. I say, keep that thought. The needle moved. And we move on, and I have a giant horseshoe magnet that I got when I was at Kent State University in the late 60s, and I used to sleep with my head between it. It's that big because somebody told me it would make me smarter. And I learned that it doesn't work. So anyway, I got this big magnet, and I put a couple of copper cradles down there, and I get a piece of thin magnet wire, strip it off, and I lay it on those cradles. And then I take alligator clip leads off with copper cradles, and I touch it to a D cell, and the wire jumps like this. And I explain the whole thing, what's going on. Well, it moved, and why did it move, and why did it stop? Why is it bouncing? Because when the current goes through, it creates a magnetic field. It causes it to jump. As soon as it jumps off the cradle, what happens to the circuit? It opens, so then it falls back down on the cradle, and it closes, and it bounces like this. And then I query the class, okay, now we've seen this twice. What is the physical phenomena that ties together electricity and magnetism? Well, it's motion of some kind. And we discuss, yes, it's the relative motion between a conductor and not the magnet, but the magnetic field. We even get into discussions on Faraday's experiments with his dynamo. Most people don't know he did 3 iterations of that. One of the iterations was he combined physically the field magnet and the armature disc together, and when they spun together, it still generated electricity. So magnetic fields sometimes are independent of the permanent magnet material they're in. And then I go on and I show, okay, I take a big long wire, and I have a beautiful old antique galvanometer, and I run the wire down through there, needle moves. Move it up, the needle moves back. Move it slow, it goes real short. Move it fast, it goes real far. And then I say, okay, that's one wire, coil it, now it moves twice as far, coil it again, now 3 times as far. And I go through the whole thing, and then I start to make the point that this relationship between electricity and magnetism, connected and tied by the physical phenomena of relative motion, we've got to start putting some terminology here. I say, when you have an electromagnetic system and you force motion in and get electricity out, that's called the generator effect. And when you force electricity in and get motion out, that's called the motor effect. From there, we jump to, oh, it's trying to start. From there, we jump to first law of thermodynamics, which I think is coming up here in a little bit anyway. You know, energy can't be created or destroyed, blah, blah, blah. But the next day when they come in after watching that video, I do another demonstration. And I don't know if this next video is going to work or not. Probably not.
They're all slow loading for now.
Okay, well then it's not going to work. Something to tell you about this one too. I have a half horsepower Leeson 120 volt DC motor. I actually have two of them. One of them is clamped down onto a board with a hand crank. And then I got chain and sprocket that drives the shaft on that. And then over here, I've just got the other motor just sitting with a couple pigtails on it. And I walk in and I say, okay, now here's the deal. We're going to build an electric guitar. An electric guitar without an amp, and I've heard this term before, I tell them it's just a piece of wall art. You know, you can't hear it. There's nothing there. To have a full electric guitar system, you have to have an amplifier. And I say, I've got a new guitar and amp system here today, and I'm going to show it to you. And I mentioned there, it's an imperfect metaphor, but we use it for discussion. So I take the crank on what is now the generator, and I start moving it, and nothing's really going on. And I say, well, why isn't anything going on? So I grab the cord coming out, and I say, because I haven't plugged it into the amp. And I have this two-conductor wire. I say, this is my guitar cord. There's an amp over there. So I take it over to the motor, and I plug it in, and I've got a disc on the shaft of the motor with a mark on it so you can see it move. And I grab the crank over here, and I go like this, and the wheel spins. I go like that, and the wheel spins. I say, so here's what I got. And again, imperfect metaphor. Here's my guitar string right here. How does a guitar string vibrate? It vibrates back and forth. And I go like this, and the disc is going like this over here. And I say, so what's going on? Well, here's my string. This thing right here is my pickup. Here's my guitar cord. Here's my amp. And there's my loudspeaker doing its thing over there. Eventually, we get into discussing, is the handle really the string? I mean, really the string? No, it's more like the pick. And the wound armature is really more like the string. You know, the magnet is like the inside there. And truthfully, we have no amplifier because we're not increasing the signal with an input of our energy. This is more whole thing. It's more like the loudspeaker. And I get into that whole thing with them. And we discuss it through. And then I get into the first law of thermodynamics, and I emphasize, can't destroy energy, can't create energy. You can only change it from one form to another, or move it from one place to another, and that applies all across all realms of the physical universe. So how does an electric guitar work? We dive right into electromagnetic induction. We talk about magnets. I get into a lot of detail on magnetism. And we talk about what are the poles, you know, oh, hey, we got flux, invisible magnetic flux leaving the North Pole, entering the South Pole. And interestingly enough, most people never notice in my classes anyway, it's a beautiful, symmetrical toroidal vortex between the two poles on this magnet. And I show them that once you start to, and I talk about magnetic materials that can basically attract and distort the shape of that field. That perfect little toroidal vortex there will be misshapen and distorted if you put a ferromagnetic material near. And once it ends up pictures of things like, here's two magnets interacting, and if you put a piece of steel down there, it's going to interact, and the field is going to do this. It's going to undulate and distort. Then we start digging into what the pickup itself is. The pickup is a permanent magnet, and that permanent magnet is wrapped with a whole bunch of turns of real small magnet wire. The guitar string is a ferromagnetic material. It's a steel guitar string. Try doing this with gut strings on your electric guitar. It's not going to work. And the strings are centered over the poles of the pickup. Now, as the string moves away from the magnetic pole and back and forth like this, even with all of those rich harmonics and overtones, that magnetic field starts to undulate and vibrate around that magnet right there. And that undulating magnetic field is cutting across that coil, and that's inducing a voltage that perfectly matches the vibration of the string. And in perfectly matching the vibration of the string, we then send that through a guitar cord over to an amplifier, and then back to the first law of thermodynamics, we actually inject energy into the system and electronically boost the voltage while maintaining the perfect waveform of that thing, and then when it hits the loudspeaker, what's a loudspeaker? It's just a motor. It's an electric motor. It's an electric motor that moves back and forth instead of round and round, responding to the AC, or what I like to call the wild AC, current that we're sending it. And here is my field magnet right there. There's my wound armature. The thrust is linear, back and forth with the alternating polarity of the signal. And so what we've got is back here, we have an electrical generator, and right here, we have an electric motor, and then I go right back over here. Here's the electric generator, here's the electric motor, and they get a little bit more understanding of electromagnetic induction and a little more understanding of how their capacitor works. And I did that a lot faster
I
than
think about 4 minutes left.
Yeah, that's because I had 15 minutes of video on it. So
That's okay though, because with the way that lunch ran and everything,
Yeah.
it's all good.
Yeah,
Thank
so
you very much.
Yeah, the presentation's in the video.